Now let's look at some tips and tricks for using selected signal assignments to make them more compact and more readable. So the traditional way to using a selected signal assignment is to actually list out every output condition for every possible input code, and then remember you have to create an internal vector. So let's get this model working, and then let me show you a few tricks here to make it a little bit faster and cooler. Okay, so the first thing I'm going to do is, this is a new simulation, so as always we're going to come in here and create a new folder to hold this, and I'm going to call it master ex select sig assign, and that's where it's going to be. The test bench is the exact same as the conditional one that we just did, so I'm just going to copy that into there, and then I'm going to come into model sim. I'm going to fire up a new project. I got to browse to where I'm at, so I'm going to be in selected signal assignment, and I'm going to call this project, and then I'm going to say OK. It's going to ask me, you want to add a file? I say yes I do. I want to add my test bench, and I make sure I'm in select signal assignment, and then I say you want to create a new file, and I say yes I do. I want to do master ex vhdl, and I'm good to go. Alright, so I'm up and running, and the first thing I want to do is I'm going to check my test bench, make sure there's stuff in there. I'm going to check my regular file, and there's nothing in there. So what I can do at this point is I can start typing in my code. So the first thing I'm going to do is go N to T, and I type that in as fast as I can. And then what I'm going to do is I'm going to do my architecture. So I come right here and I do architecture. And then I'm going to do, remember now I'm going to set up my internal vector that I'm going to use. And then I come down here and I'm going to begin. And then I'll go X, Y, Z gets assigned. X concatenated with Y concatenated with Z. And then finally I'm going to enter in my selected signal assignment. And I'll move this little baby up there, give myself some room. So to do this, what I'll just do is with my vector and select. Okay, so let me do this. What I want to do is do that and that. Okay, all right. So I have it, and I just got to end my architecture and architecture, and there we go. Okay, so we should be pretty close. Okay, so let me save that, and we'll go ahead and do compile all, and they should both turn green, hopefully. Can't see my transcript, but with warnings. Okay, got to check that out. So let's do this. Let me clear this out here. Actual length is 4 conditional signal assignment. Okay. Oh, whoops. I have this as 2. Sorry about that. Boom, boom, select. Okay, successful. Success. All right, so let's get our simulation up and running. We do this every single time, so it's good to just get a lot of practice with it. When I load the simulation, the window resizes like crazy and blinks, and so you just wait till it stops blinking, and then you can resize. If you try to resize it while it's blinking, it goes nuts. So you just give it a little second to recover, and then we can resize it. Okay, so now the simulation is loaded. Let's see what our windows look like. I got my waveform. I'm going to add 2 wave signals in region. I'm going to go ahead and combine these babies immediately to X, Y, Z so that they're readable. So I go X, Y, Z, and I go boom. I nuke these. Boom. I'm going to run this for 80 nanoseconds. I go fit. Look at that. And let's change the radix of this to unsigned. Life is good. I got an assertion for row 1, row 4, and row 7. Okay, so that's the traditional way of doing it. It took a few minutes to do, but it was worthwhile. All right, so now let's see what kind of cool things we can do. The first thing that we want to do is there's an others clause that you can use in a selected signal assignment that can cover all possible input codes that aren't listed. So I'm gonna copy and paste my selected signal assignment, and then I'm gonna let's see, it's hard to see that. I'm gonna do this. I'm gonna go boom. More, it's off the screen, but I'm going to comment select it. Okay, so now what I can do is there's this other thing where I can say give it a 0 when and keyword others. Okay, and so that allows me to basically cover all the input conditions that I didn't explicitly list. The reason that's neat is because then any code that corresponds to a 0 I can actually get rid of. So that allows me to just list the explicit codes for ones and then cover all the other ones with this when others clause. And this is analogous to having the else clause in the conditional signal assignment. But look at how compact this is. I mean, it's immediately super compact. So I'm going to save that. I want to make sure that it's okay. So I'm going to compile here. So let's do a, let's get that baby on the screen. Compile, selected, successful. Okay, make sure it works. I go back in here. I restart my simulation. What's fun about the resizing of the windows is the menus are always in random places. So, okay, it worked. All right, life is good. Now, how can we make this even more compact? Well, the selected signal assignment actually has something that's even cooler than the conditional signal assignment. It has a pipe delimit. And let me copy and paste this, and then I'm going to comment it out so that I don't lose it. Okay, so now here's my new working one. What you can do is on one line, you can actually pipe delimit multiple input codes associated with that output. And the pipe is the little stick, the little up and down, what do you call it, vertical line. So what I can do is I can list these on one line, and that allows me to do this sort of thing. So I can actually get rid of this and look at this. So now I've got, it's a 1 when you go either a 1 or 100 or 111. Now that is getting really compact. So let me go ahead and make sure that that syntax is correct. So it's successful. And I just verify that the simulation still works. So you go boom, boom. Okay, we're still running. And that's really readable. The last thing that you can do is do the little trick where you say, I want to use hex symbols. So let me go ahead and make this a 4-bitter. I can now turn my internal signal into a 4-bit vector by padding it with a leading 0, which has no impact on anything. And then that allows me to do the following. So let me save a version of my code down here, and I'll comment that out. And it's off the screen, but I'm going to do comment selected. And what I'm going to do now is put hex symbols here. So instead of saying 001, I'm going to go hex symbol 1. And that's the exact same information. Remember, double quotes are on hex. But that allows us to do 4 there. And then this is really cool. You go 7 there. Now look at how readable this is. I mean, you get a 1 when X is a 1, a 4, or a 7. Make sure that that works. While selected, it worked. Make sure that it actually ran. So I come back over here, restart the simulation. Boom, it did work. Sweet. Okay, now think about this. Look at how readable this is relative to the original project description. So if you look at the minterm list that we're trying to code here, I mean, look at this. Look at this. XYZ asserted for 1, 4, and 7. And you say it's a 1 when you get 1, 4, and 7. Otherwise, it's a 0. It's perfect. I mean, this is very, very compact. Okay, that is some tips. Those are some tips and tricks for the selected signal assignment.